Here is your overview of the C7 topic to do with cracking and alkenes. So in the previous lessons we looked at the process of fractional distillation, which was used to separate hydrocarbons according to their size order, which relates to their boiling points. And we found that when we did fractional distillation, here's a very rough sketch, we put crude oil at the bottom and the hydrocarbons were separated with the small ones at the top and the larger ones, longer ones at the bottom. The smaller ones are useful as fuels, but as the molecules get larger and larger and larger, they become less useful as a fuel. So, small ones are the useful ones, but the demand for fuel has also increased over the years because the population has increased and our energy demands have increased also. So how do we take the larger ones and turn them into fuels? Well, we do a process called cracking. Cracking involves taking a large hydrocarbon and breaking it at a particular point to make two smaller ones. The break point can be random really, it can be at any point along the hydrocarbon, but we always end up with two smaller ones compared to what we started with. This is a process of thermal decomposition. We use heat to break the molecule. So you take your hydrocarbon, you heat it up, and that causes it to vaporize, which means it goes into a gas. And then once you've vaporized your hydrocarbon, you can do one of two things. You can either mix it with a hot powdered catalyst, and this will lower the energy activation energy, so your molecule is more likely to break at lower temperatures. You can then also react it with steam, and this has to be at a high temperature, and this also causes the molecules to break. So the products that you would get from this reaction, if you were to take this alkane with 7 carbons and 16 hydrogens, once this breaks, you would then form two smaller molecules. The first one I've broken at C5 to leave C5H12, so this will produce an alkane because it fits the formula CnH2n plus 2. But then if I look at what's left over, C5 from C7, so that means I've got 2 carbons left. I've then used 12 of my 16 hydrogens I had at the beginning. Well, that means there's only 4 left. So the molecule that we now make can't be an alkane, it has to be an alkene, which has the formula C2H4 in this case. And we can always check because the number of carbons and hydrogens in our products equals our reactants. So what are these alkenes that are produced? Well, alkenes will have the general formula, not CnH2n, but CnH2n, 2n plus 2, but CnH2n. They have a double bond in replace for one of the single bonds, and this is called its functional group. So all the alkenes will have these. All the molecules end in -ene, we'll come on to those in just a moment, and because of this double bond we can classify these as being unsaturated. You can test for an alkene by adding bromine water to it, and bromine water will change from being orange to colourless because of this double bond. So here's an example of the alkene that we produced in our reaction. Here it is here. This is ethene. It's got 2 carbons with a double bond in the middle, and it's got 4 hydrogens. The reason it doesn't have 6 hydrogens like ethane is because each carbon can only have 4 covalent bonds. 1, 2, 3, 4. And this carbon can only have 1, 2, 3, 4 again. If we were to put 2 hydrogens in, this would be a single bond, and we wouldn't have ethene, it would be ethane. So this double bond reduces the number of hydrogens. Naming the alkenes is very simple. We use the same terminology that we use when using the alkanes, except we can't have methane because we can't have a double carbon bond with only 1 carbon. So this doesn't exist. We've got ethene as the first one, then propene, butene, pentene, and so on. We only need to know the first 4. Here's an example of how to draw one. So I've taken here, we've got butene. So we've got 1, 2, 3, 4 carbons with a double bond in the middle. You could do the double bond between carbon 1 and 2 or 3 and 4. It doesn't make any difference. But as long as you follow the rule that each carbon has 4 covalent bonds, 1, 2, 3, 4, 1, 2, 3, 4, and so on, and each hydrogen has 1, you will end up with the correct formula, which should match the general formula. So overall then, cracking produces an alkene, and we do cracking to try and make small hydrocarbons from larger ones, and this will be more useful as a fuel compared to the larger hydrocarbon that we started with.